Okay, yeah, so my name is Jide Abdul-Qudus. I'm a software engineer and also an AI enthusiast. And today we'll be talking about how to build reliable workflows, pretty much engineering AI systems that don't break in production. As we all know about like the buzz with like AI and like incorporating AI to like your product, so it's like your tool. So we'll be touching more about like that and like how to engineer these systems pretty much. Yeah, more about me. I grew up in Lagos, Nigeria. I taught myself how to code in 2018, and I wrote my first program the same year as well. So I can say I've been writing code and programming for like the past 8 years. I currently live and work in the United Kingdom as a senior software engineer. And luckily for me, my work allows me to explore my interest in AI and also like adapting it into my work itself. So today, these are the contents we'll be covering over the next few minutes. We'll start from like understanding the evolution of AI, why workflows matter, and then we'll go deeper into like the reliability system, which pretty much allows us to like understand like the 3 failure modes that we'll be covering today. For each one, I'll show you the architectural pattern that solves a particular issue. And if time permits, I'll be able to like share a video demo of an app that I built using like this system that I'll be sharing with you. But before we start, I'd like to get some interaction in the chat. So if you guys like drop where you're joining from, or like what AI system you're building, what's your go-to AI model? Just pop some things in the chat for me and let's have some interaction to start with. I'll be taking notes of. So yeah, where are you joining from? Or like what system are you building? What tool are you building? What's your go-to AI model? Okay, we have someone from Washington, DC here. That's nice. India, Nigeria, Claude. Cool. That's good. It's like a whole lot of people making use of Claude these days and building tools with it. Niagara Falls, Canada. That's really good. Gemini, Saskatchewan, Canada. Okay. We'll have people joining from Canada over here and someone from India. AI assistant for observability using Claude. Cool. ChatGPT. Yeah. Yeah, so we're getting like Claude, Gemini, ChatGPT. I haven't seen anyone mention DeepSeek. Okay. Resilience RAG. Okay. The US. Some Perplexity as well. Okay. Ajigula Lagos. Behavioral intelligence using Codex. Okay. So yeah, from what I can see on the chat, it's pretty much obvious that like a whole lot of people are familiar with like AI tools. People have like quite a whole lot of interest in like building like this software, and as you can tell, like we have like a wide range of like softwares that could actually like get the job done in terms of like what you're trying to build or like how you intend to go about it. So we could begin for like talking about like the evolution of AI itself. AI didn't actually start like ChatGPT or with like Perplexity or with Turing or with Claude or whichever tool that you make use of. We had the Turing test as far back as the 1950s. Then we had like deep learning in 2012 with AlexNet, if you've heard of AlexNet before. Then traditional AI in 2020, which is probably like where most of us pick AI from. And then 2023 hits and we got like generative AI with like GPT-3, DALL-E, and then suddenly AI can like write essays, AI can like generate images, which is like pretty amazing for like doing demos, right? But it's terrible for like building business tools, terrible for like reliability. Between 2023 and 2025, which is this era here, we're like in the chatbots era where like everyone's building like GPT wrappers. Everyone is building, we're having like the same conversation over and over again with like whichever AI tool we're making use of. And now 2025 and beyond, we're like in the era of like agentic AI. who are shifting from like agentic AI to like writing like workflows. This is like where AI doesn't just answer questions, but it actually like executes multi-step business processes for us. So that's where we are. And the challenge is for us is that we're building tools such that LLMs and APIs were built for chats, not just for workflows. So we have to like engineer around that. That's like the job we're trying to like solve, right? So why workflows? I mean, we've been talking about like workflows for a while now, but we've all experienced like a loop, like this one in particular, whereby like we're extracting customer emails from CSV and like trying to like categorize sentiments, having like conversations with like ChatGPT, for example, and then as you're prompting ChatGPT, like generating like it's losing context along the way. You're getting like different structure, and then you try to go back, it loses context, you try to go back. And the reality of it is like chatting is like manual labor. You're not automating anything if like this type of conversation you're having with like your system, whereby you're asking it the question and you're getting like response back. And if you have to like prompt it every time, you haven't like really automated anything. You've only like changed who you're talking to. So chatbots in the real sense are like Q&A masters on like workflows, which is like AI that actually like executes multi-step tasks. AI that actually like build something or you can like incorporate into your business. For instance, we have someone trying to like build like a residence RAG system, which like retrieves data and also like gives you back information, right? So that's how you want to build a workflow on top of that, as opposed to like having like a chatbot, which pretty much just does you giving it the question and getting back answer. So an example of is what I've showed here on the right side, whereby we're having like conversations with like whichever AI model we choose, and along the line, it tends to like lose context as the chat expands. So we have agentic workflows, and we have like the AI agents, right? So see your agentic workflow and your AI agent as how do I put it? As a tool within like an entire system. So imagine you're going to like a factory that produces cars, for instance, and you have like the belts, right? An AI agent would be like one of the items within the belt, but like the entire belt itself would be like your agentic workflow. So your AI agent is like a standalone decision maker, right? So that's like your chatbot, for instance, and it executes like those tasks based on the inputs that has been given at a particular point in time. Unlike your agentic workflow that like encompasses multiple agents, and for instance, your agentic workflow could handle your planning, could handle your execution, it could handle like the implementation, also like get feedback and also like work on top of that feedback. Your agentic workflow as well, unlike pretty much AI agents, you could expand its memory for like long term, so it could like recall states, could like come back and also like give you like reports on like things that you've made mention of. It could also like involve humans in terms of like if it believes that confidence rating is quite low, and then it pops back like the memory and gets like reviews for you. So that's pretty much how you differentiate with like agentic workflows and like the AI agents that you see these days. And okay, before we get into solutions, we need to understand that what makes AI workflows fundamentally different from traditional software, as we call it. So traditional software, which is like the software that me and you use in the day-to-day, is quite deterministic. So say, for instance, now, you write, if urgency is greater than 8, return high. Or you write, if A is equals to B, then return C. For every single time urgency is above 8, for every single time A is equals to B, it always gets C forever. That's what makes it deterministic. So what that means is that for every input that you give it, you get the same output. On that, you can write unit tests that cover like every code within that. You know every possible failure. You know how to like tackle failures or how to like manage failures with that particular pattern, right? Unlike your AI augmented workflows that are like pretty much probabilistic. Say for instance now, you're making use of ChatGPT, or you're making use of like a Claude model or a Gemini model, and then you ask the LLM to classify urgency for you, just like the previous example I gave. And sometimes it says high, or sometimes it gives urgency as urgent. or sometimes it gives you a score out of 10. It could say like urgency is 9/10. Or sometimes you could even write a full-on paragraph of like what urgency is at that particular point in time. So if you're building a system to like classify, I could use an example of emails or like customer emails. You're running a business and you want to like get feedback from like customers, or if customers are requesting for like an item back, how you'd want to like build on top of like an AI augmented workflow, it will be a little bit different because you could have like same inputs, but your outputs would always be different. So how do you want to like handle getting like different outputs whilst building on top of the same inputs is one thing. And the reason why these things happen because it could be because of like a varying reason. So it could be because of like temperature settings or model version updates, or even context window limitations. Like a dozen of factors could literally affect how you'd want to like get like probabilistic data back. And here's the kicker, right? AI doesn't just feel predictably, right? Unlike traditional code, it feels creatively. So what that means is that you could get back, it could hallucinate, but it makes stuff up that sounds very plausible. So today now you could ask ChatGPT if 2 + 2 is equals to 4, and it'll tell you that yes, it's equals to 4. But if it's going to tell you 2 + 2 is equals to 5, it would sound very, very confident that 2 + 2 is actually 5. So the engineering challenge is how do you build reliability on top of unpredictability within that particular system? Yeah. So I already made mention of a few items now, but I'd like to know from you guys as well, like what do you think has been like the biggest production challenge that you have encountered so far in your experience as an engineer, or like as someone that has been building with AI systems, as someone that is enthusiastic about AI systems? Just put A in the chat if it's getting consistent outputs from the model, or B if it's monitoring and debugging issues, or C if it is like costs, or D if it is all of the above. Okay, A. I'm seeing some A's and some C's and some D's. Okay, that's the set C. Mike said A, C, D. Well, D is pretty much everything in one. Managing customer skills, just really going to have it. Yeah. Okay. Yeah, so it's like a whole lot of varying options. Some people are an issue has been like getting consistent output from the model, which I pretty much agree with, because like I made mention of previously, you could be prompting your AI, and sometimes it's going to give you, if you're asking it if urgency is greater than 8. I keep using that particular example because it's more practical. And if you're asking if urgency is greater than 8, sometimes it tells you that, oh yeah, it is high, which is basically just like a string of text instead of an integer. Sometimes you could give it like a whole sentence, which if you're trying to like get your outputs back and you're trying to like push it back into like your application, makes it a whole lot difficult, right? So consistent outputs is like one of the major issues. Monitoring and debugging as well. Like a whole lot of people report that they could have like the AI model running in production, and as at the time when they would push their app and they get like customers that will make use of their products, they get their model just happens to like crash and nothing happens, and they don't even know for like ages. Managing cost at scale, I've been a victim of it personally, because I've been in a situation whereby I test like a model on like my local, or I test like 10 users, right? And my bill is probably like running into like $50, and I'm like, okay, cool. And then at the end of the day, you just push, and then you have, at the end of the month, you get like a bill over like $5,000. So yeah, all of the above would cater for it all, because now all of the experiences, all of the issues are like things that we've all like encountered one way or the other, and which is what we're trying to like solve. Yeah. Just to proceed. So as I made mention of, the 3 biggest failures in workflows or like AI systems in production happen to be inconsistent outputs, the silent failures, and the uncontrolled costs. Each one of these failures that I mentioned here are areas that I'll be catering for, and like to share with you an architecture that like actually like helps in resolving these concerns. So failure mode 1, which is inconsistent outputs. So here's what that looks like in practice. You ask the AI to extract an email from a customer sheet, maybe like an Excel sheet, and you ask the AI to extract the email. So customer name, and the first response that you get is maybe you ask it on a Monday, and then you get john@email.com, which is literally what you wanted, right? And another time that you actually like prompt the AI to get like response back, instead you get like John Doe, because now the model is looking like the Excel sheets that you provided. It can see multiple columns. Perhaps in the columns of fields, you can see like the email field, you can see like the name field, you can see like the mail classification, you can see like the subject of the mail itself. So you could see all of these details, but AI being AI and it's been probabilistic, like I made mention of, it just picks off the name of the user at that point in time, and then it returns John Doe to you. This inconsistent outputs on a large scale on like a production application would tend to like break your app in various instances. User inputs is also like another example whereby you classify urgency in different ways, and by it could give you like high today as the urgency, and tomorrow you could literally return a response of like 7/10, and another day it could literally just give you a response of perhaps just 8 without even having the over 10. All these examples are like things that actually like end up like breaking your application in the long run. And frankly speaking, this is like the most common mistake I see. People treat AI output like a string from a database query. It's pretty much a probabilistic blob that changes that changes shape every time you call it. So my question would be like, how do we fix this? Does anyone here actually have an idea of how we go about fixing this? I'm going to cover it, but just like insights. So if you have an idea of what comes to your mind as like someone that has built the product before, or someone that's an engineer, how do you go about like getting like varying data from like your AI system? If you have an idea, you can just put it in the chat. Wait the review agent to check the responses, okay? Any other response, any other thoughts, any other ideas on how you could go about fixing this? Give it a guide, maybe an MD file. Well, yeah, that's one. Okay, someone's asking what the question is. So what I'm asking is, with inconsistent outputs, whereby you are getting different outputs from your AI model, which like each input you're giving it, how do you want to like tackle this problem? For instance, now, programmatically to start with, how do you want to like tackle this problem? That okay, I'm asking it for like user input, and I want it to extract customer name, and it's giving me the email instead of the name. How do you want to like treat it? How do you want to handle this? Or you're asking it for the email and it's giving you the wrong string instead. You're asking it to classify urgency, and what you need is an integer, but it's giving you high. How do you want to like handle this? So I've gotten like some really brilliant responses, to be honest. Solomon said, create a review agent to check the responses, which is great, right? But that's giving us additional cost if you think about it. And we're also trying to cut costs while building like these workflows. Someone said give it a guide, maybe an MD file, but you also need to understand that AI is quite probabilistic, even with the MD file. Remember, whenever you're prompting your AI, you add like the inputs that you tell the AI via prompt, initial guidance to AI will help. I really clarify my inputs. That's good. So what happens is the best architecture, the best solution to this sort of problem is something I call the validator sandwich. And this is my really cool looking sandwich here that I built using Nano Banana. So what this does is we have 3 layers in our AI model, like in our prompt. The first is the input validator, which, the first is the input validator, the second is the LLM layer, and then the third is the output validation. So what this does is that we sandwich our AI model between like these 2 these two bonds, which is like the input validator and like the output validation. So the input validator, the input guardrails, what that means is that before anything touches the AI, you validate it. Is it an actual email? Is this text with within the length limit? Is this user authorized? If not, reject it. So that way, you're able to like handle your system in a very fast, cheap, and deterministic way. So you don't just waste API calls on like garbage data, right? So just like Solomon said, having like a review agent. But if you actually have like your top bond, which is like the input validator, right? You're able to like with deterministic code, you're able to like validate what your model is going to accept before like giving it out something to make sense out of it. Then the second bond or the middle bond is like the LLM itself. But here's the key. You want to like force your LLM to return structured outputs, right? So you're using JSON mode. I'm sure most of us would have heard of like JSON mode, like our models while working with them. So you'll be specifying like an exact schema in your prompt. So that way you're making the AI conform to your format, not hoping it does the right thing. So the AI actually has to follow the format in which you've given it, and it has to like return the prompt based off of like the JSON schema you've given it. Then the third layer is like the output guardrails, which is like very similar to the input guardrail, just a little bit of like quality assurance or like schema check that you're doing. So you've gotten a response back. Now you want to validate it aggressively. Does it match the schema that you're expecting for your outputs? Is the confidence score above your threshold if you're trying to like rate the confidence score of like each response that your AI is giving you back? Does it make business sense according to like the rules that you've provided in like maybe like your role MD or whichever file? Like, does it make actual sense? And like if there are like any check that has failed, do you want to have like a retry logic wrapped around it, or do you want to like escalate to a human? So these are like how you just want to like layer out like your model calls with like the validator sandwich pattern. And it's pretty what if you can get it right the first time, it's pretty like reusable across like your application, because now you have like your input validator, your LLM in the middle bond, and like you have like your output validator at the bottom. That way you don't have to like you could really literally like reuse it in every like AI calls that you're making, or like in every LLM call that you're making in a very extensive manner. So yeah, about the input validation layer, right? What to validate, an example would be like type checks. Is email actually a string? So if you're receiving like user input and tossing it back to your LLM, you want to check if the mail is you want to validate if it's an actual email, or if you're getting back a string of Jane Doe. Obviously, if you're getting a string of those Jane Doe, then you know to like just reject it. That way it's really like just fast, it's cheap. You don't have to like do an extra AI call that would actually help you to like prompt again, and now you're wasting tokens and you're burning money, right? You could also like check for range, check for like the length of the text if it's within bounds. You could also have add some business rules to your calls as well. And there's some popular validation libraries that actually does this for us under the hood. So you have Zod with like TypeScript, Pydantic with Python, or JOI with JavaScript, or even using like your basic JSON schema, like writing like a utility function or a reusable hook, depending on your use case, will handle like the input validation layer for you. Structured outputs. I made mention of structured output before, which is like the middle bond. And I said how the JSON schemas. So this is where like the APIs differ, and you need to like understand trade-offs. So OpenAI, for instance, has JSON mode with strict schemas. What that means is like high reliability, but like it costs a bit more because you're using their validation layer, right? So I'm sure a few of us would have made use of like the JSON mode and JSON schema in like OpenAI with like the strict mode. But then at the end of the day, we're burning like extra tokens with like each one of those calls because you're relying on their validation. Anthropic, for instance, they don't have a strict mode yet, but you can get like high reliability by being very explicit in like your system prompts and using the retry logic as well. And even with retries, you get to like save money. And then you have like the open source for people that make use of like open source models, where you can like self-host like Llama CPP, and you can use like grammar constraints. But the best practice, like I put down here, is like always validate even if you're using structured outputs. Like you want to like validate your outputs data, right? Like you just don't always want to like rely on the model giving you back whatever it is that is going to like feed you off, right? You still want to like validate your output, because models do hallucinate most times. And yeah, so in code, for like a JavaScript example, a simple implementation for this implementation of like email or like getting query from a user would also just been validating your outputs, validating your inputs, and wrapping everything in like the middle bond, which is like the second layer that I made mention of. So this is like just a simple implementation and being able. Oh, you want me to zoom? Did that work?
No, you still haven't zoomed. I don't know if you're trying to.
Oh, I'm trying to zoom, but I don't know. I guess I'm not getting it right. Let me see if I could.
Yeah, I think you can press. Okay, you can just continue. I think that's nothing. Maybe you said
I could. Well, I'm gonna share the slides once I'm done the call. So you guys can have a go at it as well yourselves, if that'll be all right.
That works.
Okay. So yeah, the validator sandwich in code. This is a JavaScript example, anyways. So there are different implementations for people that write TypeScript or write Python or you write Go, depending on the language you want to use. But like the idea is always the same, because like every language has its own adaptation of like how to create like this JSON schemas, right? Second failure mode, which is silent failures. So this is like the scariest one, because you actually don't know what is happening, right? Your model hallucinates and sends wrong information to a customer, and you find out way too late. And maybe they call support 3 weeks later and they've gotten angry and you like lost your customer. You're trying to like build, you're trying to build like a mock interview platform, for instance, like Solomon is, and your model is like, your accuracy has degraded, perhaps from like 95% to 70% over a few weeks, because your training data or your response is using something from like 2024, 2023, and things have changed since then. But like you discovered this a little too late, but by then, thousands of records that have been processed incorrectly. Or you get like an API timeout that is silently failing. Like 10% of your requests are failing and users are reporting like your system is broken, but you have no idea why, because you're literally not logging anything. Or your bill spikes from $500 a day to $5,000 in a day, and you find out at the end of the month when the invoice hits. The principle is simple. You cannot fix what you cannot see. So if you're not logging anything, if you're not monitoring anything, if you're not alerting from day one, you're pretty much flying blind. And flying blind with AI is expensive and dangerous. So the solution to this is having observable pipelines, right? So with observable pipelines, you can log everything, you can monitor everything, you can alert on anything. So every input gets logged, request ID, timestamp, user ID, input hash. The tools you want to use are definitely up to you, but basically every LLM call gets logged. What model, what was the output, what was the confidence score, how long did it take, how many tokens, how much did it cost? Then you have your confidence check. If confidence is above, let's say 0.8, then you can auto process the request for the user and log that decision. If confidence is below 0.8, you can set it to a review queue. I've seen instances whereby if confidence is really low, then they send it to an actual human to review them. So the idea with AI is not to like take my job as a human or take the job of a customer support worker, right? But it's to instead like help them, like to assist whoever is behind the system a whole lot more. So imagine, for instance, you're working at an e-commerce company that gets like a whole lot of mails from customers talking about like they're looking for their products, or they want to know where their products is, or where their item is, where their order is, but they want like refunds. And you have about like you're getting about like 30 mails per day, and you have to like respond to like every one of them per hour rather. if you have like an AI system that actually like triages those and like breaks it down in terms of like urgency, and it auto responds to the ones that it believes that, okay, yes, the confidence rating is a bit high, and then you could all like just manage the ones that are like with very low confidence, and it sends it back to you. That way you're able to like manage your system properly. So which is the idea of having like a monitoring dashboard that you're tracking with each one of like LangFuse or Datadog or Sentry or PostHog. You can track like a confidence distribution over time. Is it shifting to the left? Is the model degrading? What's the response time like? Is latency spiking? What's the error rates like? Am I getting like a sudden increase, or is something broken? Or with every response that like I'm getting back, is there like a human override rate? Or like people that are making use of my product, are they like rejecting AI outputs more often? I'm pretty sure like a whole lot of us have gone into like ChatGPT or Gemini or Claude, and whenever we prompt it and it gives us a response back, you can see like a thumbs up button or a thumbs down button, or you get like a neutral button. So that way, how are your users interacting with like each one of those buttons? Are they overriding the AI responses quite pretty much often? Are they like getting like AI outputs back, or they are satisfied with like what they're getting? And like I did make mention of, you don't need all of these, but you can decide based off of your use case. LangFuse, for instance, tracks prompts and like cost latency, and Sentry captures like exception and some stack traces and whatnot. There are like a whole lot more other tools out there, but like these are just some of the ones that I'm quite familiar with. I decided to put them on here. Yeah, uncontrolled costs. Someone made mention of uncontrolled costs the other time, and yeah, with uncontrolled cost, which is like the failure mode 3, this is like where things get expensive real fast. So let's say you test with 10 tickets, or you test with 15 tickets. It works great. It costs perhaps 50 cents. You deploy your app to production, 10,000 requests hit your API in the first hour. And like, wow, the product owner in you is really excited to like have a whole lot of like requests in your application. But then your bill at the end of the day is probably like $5,000, and you're wondering where that amount of money got spent on. Or worse, you have a bug on your application, and instead of having like exponential back off, you retry infinitely every 100 milliseconds, and your bill at the end of the month has grown up exponentially. Or something that I've seen a whole lot of people do is like they use a large language model for something that can be handled with like an SLM. You're using ChatGPT-4 for everything, including tasks that a model 10 times cheaper could handle. And then you have like certain users that are just prompting your model with "How are you?" or "Good morning," or with like how can you help me? That way you're burning money because you didn't actually benchmark. The reality is, what works for 10 requests does not equal is going to work for 10,000 requests, because scale changes everything. And if you don't plan for it, production will teach you painful lessons. The solution to this is what I call like the gated pipeline with circuit breakers. So think of this as a series of blast doors a request must pass through before it earns like the right to cost you money. So see it as having like 3-4 gates, and you want like your request to go through each one of these 3 gates before it actually like gets to the point where it makes or it fulfills the request. The first gate could be like your rate limiter per user, right? So 100 requests per hour or per endpoint, or 1,000 requests per hour. A whole lot of like the software or like AI models that will make use of do this already, such a way that say ChatGPT, for instance, if you're on the free tier of ChatGPT, depending on the model that you're using, at the end of the day, it could tell you that, oh, you've already surpassed your usage for this day, and you can't do anything until like it's another 24 hours. So that way you're rate limiting your user. Even users that are like paid users get rate limited because of like exponential usage, right? You want to like also like implement case check. So like let's assume that's like the second gate. You hash the inputs, you check Redis, for instance. If it's a cached hit, then you return like the cached response. That way, you don't have to like make an API call. You don't have to make like an LLM call. It's free, it's instant, and if it's a miss, okay, then fine. Go ahead and continue like your implementation. Your request queue is also like something you could implement while like building out like your back end. That way, you don't have to like call the API directly. You queue the requests, you process them in batches. That way, it prevents you from opening 500 simultaneous connections and overwhelming the API or your server. You'd only like batch those requests in like simultaneous ways, or like even your circuit breaker, whereby your API fails 3 times in a row. Then instead of making sure the user keeps calling the same API for like 5 minutes, you give it time to recover. You prevent failures, and that way you're not wasting money on like failed requests. Each one of these gates is like pretty cheap to operate, and together they can protect you from like runaway cost and like having like system overload. Putting all of these architectures that I've shared together, then we have like the multi-agent architecture, which is the input layer, the orchestration layer, the validation layer, and then the observability layer, which pretty much is like each one that I've covered for having the inconsistent inputs, the silent failures, and also like invalidated costs. So then you have like the multi-agent architecture, which is something that you could also like just run your application and like build all of this in. And yeah, I built like a simple application following this architecture. It's pretty much a play around application, but it's something that I've seen production systems incorporate or like build as well. And what this does is, using the example that I've used for the majority of this talk, having an e-commerce platform with a whole lot of customer cares, and then you're being bombarded with requests from your users. Oh, where is my item? I want to get a refund, or I want to like exchange my product. Then you're getting like hundreds of these mails in a day. But then you as an agent, you want to be able to like handle those requests, but you also want to be able to like handle requests that are only important to you, so you could focus on like other items. So if your confidence rating is low, then okay, fine, I can handle that request myself. But if it is very high, then it's something that the AI can handle. So with this product or with this demo, what it does is that it segregates those requests. It classifies the urgency of those requests, and then it auto responds to the user's mail based off of like based off of the mail that they've sent. And if the classification is like very low, then me as an agent, I can then now respond to it. I'm just gonna play this in full screen. It's a short demo, but let's see. So with this, you have like the mail that will come in from the user, and then you have like the JSON response that I made mention of earlier on, and like the classification if it has to be reviewed by a human. So like I made mention of, you're forcing like the model to give you an output back in an object form. You're forcing the outputs to come the way you want, the way you've defined your schema. That way, whenever the model is processing the response, then it gives you back like the predefined output, and it's not just returning anything. So if you've defined categories as like enums, for instance, you want it to like stick to the categories that you've defined for it, and you want like your response to be defined as well. You want it to like follow the structure that you've also like defined for it. Okay, so yeah, that's pretty much like the idea with this one as well, whereby it's able to like categorize this with like, oh, this is other status, and subcategories is like an item is missing from what's that gotten from like the mail body itself. you could also like see the model that was being used for this particular one, because it was like a low fidelity one. And I made use of like a low scale model as well. And I, as the agent, can start to like give feedback for that review and click on if it's a terrible response from the AI, or if it's a great response from the AI, depending on like my level of interest. So to put it all together, the full multi-stage architecture is what I used to like run this application. Obviously, it's a very short demo, but then it covers like each one of the area of like inconsistent output, handling like certain failures, and even like managing costs. And yeah, if there are any questions, I'm open to like answering the questions over the next few minutes.
All right. That was a very awesome presentation. Like, I honestly learned a lot, especially in the aspect of cost, on having uncontrollable costs. Because I had a time where I deployed a mock interview platform to production, and we racked up $400 in bill immediately, and that wasn't funny. So we had to implement some of the things that you talked about here to kind of reduce the cost. We also had like cases of hallucinations a lot.
Yeah.
When someone asks questions, right? And then the AI would return, when the AI wants to ask the user a question, the question will not relate to the job description that was passed by the user, right? So we had cases like that, though the one that was really terrible was when a user actually tweeted, one of the response, and that really got us into like some kind of unstable state. But cases like this are things that happens, and if you are not able to implement systems like you have mentioned to catch out, to cut out all these issues, you would have a terrible AI system. And I think with what you've explained today, it really makes sense that we have to implement this, and even in code as we have learned them in theories. So I'm actually going to wait for people to ask you questions, and if you have any questions so far, just raise your hand, or you can drop it in the chat, and I'm going to read it out.
Yeah. Open to questions.
All right, so there's this one. How do you foresee this process changing as the business scales?
Yeah. So in terms of like the architecture that we've provided, right? In the actual sense, for large scale or like large scale production platforms, it caters for like each one of those layers, the input layer, the orchestration layer, the validation layer, and observability layer. There's some AI systems that don't necessarily like require like all of these, especially if you're building like a medium to like small scale platform, and you don't want to like end up like spending bunch of your runway with implementing like the entire observability stack. So even having like a simple like console output that does like runs on your server would work. But then handling like large like production systems, you want to like consider having like each one of like this architecture that I've made mention of. Obviously, you don't want to like skip like the validator sandwich that I made mention of, which pretty much handles validation of like your LLM without even spending a dime with like deterministic code. So things like that are where you want to like put much more focus on. Then if your business has grown, then you can now move further into, say, you want to apply like the entire observability stack depending on your use case.
Awesome.
Cool. So Mike says, how can we quickly see an issue when AI is failing on large scale platforms before it affects the customer? Yeah, so that's pretty much what the observability stack does. LangFuse, for instance, without me doing any ad, is literally an LLM observability platform. So it tracks like your prompts, it tracks responses back from like your prompts as well, and like the rating as well. Datadog have like very decent infrastructure monitoring that also like handles this case. So LangFuse is like a very good source for like LLM observability that I'd make mention of. There are also like LLM as a judge tools out there that also like satisfies that particular skill. So on large scale platforms, before it gets to your customer, you get like those logs and like how they've dropped in like responses, how they're degrading in responses, pretty much. Yeah. So aside like these tools that I made mention of, like I said earlier, there are like other tools that actually like handle LLM observability, that handle that you could wrap your application on. Sorry, that you could wrap your application on and get like metrics back. I believe like tracking is something you want to do in the early stages of your application, right? You don't want to like leave data is life, as they say. So you don't want to like leave data out there in the world without like getting like response back, or like knowing what your users are encountering or what they're facing in general. Yeah. Agentic memory. In what sense do you mean agentic memory? Do you mean like in terms of like RAG, like Pinecone, or what exactly? You could unmute your mic, by the way, if you want to speak as well. Oh yeah, Pinecone is a decent one that handles like context usage, and it's been used extensively in like RAG implementation. So if you look up Pinecone, I believe that should satisfy your use case. You're welcome.
Yeah, and recently I was reading about MongoDB now diving into creating memories for agentic systems. So it's still new, but it's something that you can also look into. I mean, MongoDB has been like the #1 NoSQL database, and I think coming into agent is going to be really great. And then there's also Qdrant also for
yeah. Yeah, that's a good suggestion as well. So in the absence of no other question, I believe
will we get the recording?
Yes, of course, they'll be recording for the call. And yeah, thank you very much, JD, for this workshop. This is really, really impactful. And yes, Eko, you're going to get the slide if JD is going to be
yeah, I'll be sharing the slides with you. You can give them to the attendees. That's fine.
All right. So thank you very much for the lessons that you've passed to us. It was really, really wonderful, honestly. It was a nice presentation. I really love the fact that you broke down everything, and then you also shared some code samples that you have used even in your own product, and that was really, really great. And also some of the pipelines that you've mentioned falls in line with what we are going to be teaching in our upcoming bootcamp. So in our previous workshop, I don't know for you guys that were there, we broke down the 6 layers of building a very production-ready AI system. And what JD actually shared today falls in line with that, because we have the validation. I think he's calling it validator sandwich. Of course, we have our own name, right? And then we have all of the 6 layers actually covers really how to, solve the problems that he has listed: hallucination, uncontrollable cost, and even the problem of missed outputs. Okay, like making sure that you always have the outputs that you wanted. Either you want it in JSON or you want it in text. So we have a layer or 6 layers that is going to show you exactly how to build these systems in a production manner. So we are looking at targeting 1 million users, right? So if you are to build a production ready system for 1 million people, like you have 1 million users using your LLMs, how are you going to do that? So that's exactly what the bootcamp is all about. And right now, I'm going to actually activate the early bird sales again so that you can get access to it if you want to. And also you can DM me, solomon@masterinbackend.com, to discuss about getting into the bootcamp. I don't want to waste anybody's time, but the bootcamp right now is at masteringai.dev, and you can get access to it. So DM me with the emails I've sent if you want like double installment or stuff like that. Okay, so thank you very much for joining this particular workshop. The recording is going to be ready very soon, and of course I'm going to share it to your email as you register for the event, and also the slide also from Jide. Thank you very much for accepting to share your slide. We really appreciate that. So without any further question, we would like to end the workshop here. And of course, we are planning more other workshops. And of course, since you're already subscribed to our events systems, you're going to see those other workshops that are coming up. So thank you very much, guys.